Hello and welcome. I'm John Weber, and today I'm going to be talking to you about how to use an NFS-mounted root file system. With all Linux systems, a root file system is required. This contains nearly all of the files we need for the system to run. Normally, the root file system is located in a partition of some sort, storage media like an eMMC or an SD card. However, for development, it's sometimes helpful to use NFS. NFS, which is short for Network File System, has been around for a long time. It is an early form of a networked file sharing system where a server can export part of its file system so that this can be mounted by a client on the local network. This way, changes made to files on the server side are immediately seen on the client side and then vice versa. We put together a more detailed article on how to use NFS with our products on our developer portal. I'll put the link in the video description below. But in this video, I'll walk through the process so that you can see it firsthand. And hopefully, by viewing this video and our developer portal article, you'll be able to get your system up and running with NFS if you so desire. There are three things necessary to enable NFS-mounted root file systems. First, you have to have a host computer and it must have an NFS server installed. You also need a root file system, and this needs to be exported so that the target can locate it and mount it. Second, the kernel has to be booted with the correct command line arguments regarding how to find the NFS file system. U-boot can handle this job, and I'll show you how. This is just a matter of changing the boot arguments. Third, and finally, the Linux kernel must be built with NFS enabled, and I'll show you how to do that and how to make this change persistent in Yocto. For this demonstration, I'll use a normal machine built with our Yocto version 3.0 Zeus distribution for EDMG IMX8M Plus without any customization. We'll just use a normal image. For this one, I picked TN image test, which is an image recipe that we use for test purposes. For your purposes, if you have an image already built, then you can probably just use that. If you need a refresher on how to do that, we'll put a link in the video description below of another tutorial we have on that topic. So let's go ahead and run that real quick. So I'll go ahead and set up Yocto. This is just where I have Yocto on my machine. Now I just need to run bitbake tn image test. Just to short circuit this a little bit so that we don't have to wait for this build to complete, I have already baked this image and built an SD card with it. So I'm just going to go ahead and slide this into the machine and power it on. Okay, the micro SD card slot is on the back here. Just feeling for it. And I'm going to go ahead and turn this on. And here is where my serial console comes from. This is the TTL level UART signals, and they're going to a USB to TTL converter that I have plugged into my host. I just need to make sure that this USB device is connected to my virtual machine here, and it is. Now I use the screen program. And you have to give it the baud rate, which is 115/200. Okay. I went ahead and just rebooted the machine so that you can see this thing booting up. Alright, now let's just do an LSBLK here to see that we are using the micro SD card. This is MMC block 1, and the second partition of the micro SD card is mounted as the root file system here. So we're going to change this so that instead of using the micro SD card's partition here as the root file system, we'll be using a network file system as the root file system. So I'm going to go ahead and pause here for a minute, and we're going to wait for this Yocto build to go ahead and complete. We'll be back in a little bit. Stay tuned. Okay, so we're back. The image has been built. I wanted to go ahead and wait for that to be done because we're just going to go and we're going to extract the root file system from this to a directory of our choice. We can see from here that our embedded board is still connected via serial console, so we still have command line access to that. So now we're going to go and take care of host configuration. You need to have an NFS server running on your host, and with Ubuntu, this is relatively simple to install with apt. So I'm going to go ahead and hit this. We're going to create a new terminal, And then I'm going to go ahead and install it. Well, actually, I'll tell you the command line to install it because it's already installed on my machine. So if I just go sudo apt install nfs-kernel-server, that's the name of the package in Ubuntu that contains the NFS server. I can go ahead and do that. And you can see that I already have that installed, so we're all good there. The next thing we need to do is we need to decide where we want to host the root file system. This can really be anywhere on your host file system, and the specific location is really not that important. On my host, which has a number of different virtual machines for managing storage, I selected opt/Yocto support /NFS root just because it is convenient for keeping my virtual machine storage capacity or storage requirements down. So I'm going to go ahead there and go there, /opt Yocto support. All right, so I'm going to go ahead and create a directory here called NFS root. Actually, the root file system is one of the artifacts that is built as part of the image. And so we can go ahead and unpack that to this, this directory called NFS root. So I'm going to go ahead and do that now. The way that we do that is we need to just use the tar command, but first I'll show you where that is. I'll show you where the root file system is here. So if I just do ls to temp deploy images, and the machine name, which in this case is edmgimx8mp, then you'll see a number of different files. So the ext4 file here is the ext4 essentially image. We don't want that. We want to get all the files in the ext4 in the root file system, which are all located in here. So we need to go ahead and we're going to run the tar. Because we're going to create files as root, we are going to need to use sudo for this command. So sudo tar. And then it's important to have these files have the same owner as they were packed in here. So let me just show you actually this. So since we're playing around here with demonstrating, I'll just do tar-t jf, and I'm going to show you the files that are located in here. So this is just showing you what was inside the files, what's inside this tarball. So tn-image.tar.bz2. You can see here, this is just a big listing of the files that are in here. You can see that all of this is ready to be unpacked directly into our NFS root directory. So we're going to go ahead and just cancel out of that. So I'm going to go sudo tar --same -owner -pxjf. So the P means preserve permissions, X is extract, J means it's a .bz2 file, and F is going to be followed by the file name. So then I'll just say temp deploy images edmgimx8mp tn-image-test.tar.bz2, and I'm going to untar that to a location that I've already created here, this NFS root directory. So just $C/opt Yocto support NFS root. All right, I'm going to have to enter my root password. And so just to check progress here, I can just go to cd into NFS root and just do ls, and I should see these things being populated down here, root file system directories as they would normally exist in a Linux machine. Now we need to configure the host so that the host exports this root file system to our target. And in this case, all that really means is we need to edit one configuration file and restart the NFS server. So the configuration file is the /etc/exports file. And I've already entered a line in here, and I'm just going to go ahead and uncomment it. Oops. I need to use sudo for this. Sudo. So I need to go ahead and uncomment this, and what this is just shows the path to the file path to the directory that you want to export. This asterisk here means you want to export it to essentially any target, and then these are just a bunch of flags you need to have when you're working with the root file system. So I'm going to go ahead and just write that and quit out of VI. And then the next thing we'll do is we'll restart the server. So sudo system control restart NFS kernel server. It's restarted. You can confirm that the server is running just by just running a process list. So if you do ps-ef pipe to grep NFS, and you'll see these NFSD daemons have been started. So the next thing that we need to do is configure U-boot to provide the right arguments to Linux kernel so that the kernel will mount the file system from NFS instead of the block storage that we have right now. So to do that, we need to change the arguments. So I'm going to go ahead and reboot. And since I have this serial console connected, I will have console access into U-boot. Once you start seeing this prompt, or once you see this, you can just hit any key to stop the auto boot process. And what we need to do here is we need to enter in several new environment variables. And I'll list all of those in the developer portal article, but I'll also explain what each one of these does as we enter them here. So I'm just going to copy and paste them from the article so that it's easier. You don't have to watch me type. So the first thing we're going to do here is we're going to create this argument called mmc NFS args. What this does is it sets up the boot arguments for the Linux kernel. And one of the boot arguments is the root argument. And in this case, we're seeing that root is equal to /dev/NFS. And then it's going to get its IP. This is the target is going to get its IP via DHCP, and then we're going to provide an NFS root argument to the kernel that really consists of an IP address and a path at the IP address. So we're going to go ahead and set that, and if I just want to do PRI mmc NFS args, then I can go ahead and set that. So the next thing we'll need to do is we're going to need to set up the NFS root directory, which is the directory on our on our host, and that is opt Yocto support NFS root. This is referred to in this environment variable mmc NFS args. And then we need to go ahead and set up the server IP. This is the IP address of your host machine. One of the things that you can check with this is just run an ifconfig on your host machine to see what the IP address is. You can also use other utilities as well, but I like to just use ifconfig. And then you can see that in this case, my IP address is this. I need to set in an argument, server IP, in U-boot with that. So that's what I'm going to do there. And then finally, I need to create a boot command that specifically uses all of these arguments. And so just to explain what this does, this is a new boot command, mmc NFS boot, and I'm going to run this macro, which is mmc NFS args. That sets up a new environment variable called boot args. Then I run load image. This loads the kernel image. This macro is already built into U-boot. Load FDT, this macro is also already built into U-boot. That is loading the device trees. And by the way, the image in the device trees and the overlays, the device tree overlays, these are all coming from block storage. So these, in this case, are coming from micro SD card over here. The only thing that we're using the network file system for, the network for booting anyway, is the NFS, the root file system. And then I just go ahead and run boot image right here. So that's all this mmc NFS boot is doing. Now that I'm done with that, I'm going to go ahead and save env. All right, now that's saved. All we need to do now is we need to go through the process of booting the machine. So to do that, we just run mmc NFS boot, and let's see what happens. Okay, so the kernel panicked. Why is that? Well, up here it kind of gives us a little bit of a clue. What it's telling us here, I'll go ahead and stretch this thing down so we can see a little bit more. This is VFS cannot open root device NFS on unknown block. Please append the correct root option. What we're seeing here is that the kernel doesn't understand how to mount an NFS root file system. Earlier, I might have mentioned that unless you configure the kernel to mount, to understand how to mount a root file system, or an NFS root file system, it won't be able to do that. So we need to go ahead and configure the kernel and rebuild it so that it understands how to use NFS. And I'll show you how to do that and make it permanent. In order to do that, all you really need to do is you need to rebuild the kernel, and you need to do that with these two arguments set in the kernel config. So what I have here is a patch that I've made to our default kernel configuration, and it just sets these two configuration settings here: config NFS FS and config root NFS. So both of these are set to Y in this patch. Now, how we can use this patch is we can apply that patch to our default kernel. The other thing we can do is we can just add this patch to our Yocto recipe so that the kernel is built with Yocto with that setting enabled already. So we're going to go ahead and do that right there. So this is where the patch is located. It is in metatn imx bsp. That's in our sources directory right here in Yocto. Recipes kernel, Linux, and then file. That's in a file directory underneath all of that. And that's the name of it, very long patch. And we'll put that in the developer portal as well. So you can grab that if you want to. And then you can just drop that into this directory. After we've dropped that into this directory, we need to go ahead and we need to provide that information about that patch to the recipe. In order to do that, we just need to change the variable called source URI, append, to include that path. This is only pertaining to the rescue images that we would build. You want this to be applied to just regular images. So we're going to go ahead and just copy and paste a setting here that I have. So we're going to copy and paste that in here. And all that does is it informs the recipe about this patch so that when the kernel is built, that recipe includes that patch and applies it after the kernel has been fetched. So I'm going to go ahead and just save this. So now we're done with that. I'm going to go ahead and just bitbake virtual/kernel. And we need to wait for the kernel image to rebuild. And that can take a little bit of time. So we're going to go ahead and pause the video at the moment, and we'll come back as soon as that is done. So stay tuned. Okay, we're back. The kernel has been built and we're ready to proceed. So the next thing we need to do is we need to take this new kernel that we've just built and we need to put it onto our SD card. The way that we'll do that is pretty simple. I'll just pull the SD card out. I'll turn the power off first here. So pull the SD card out. I'm going to slide that into my SD card adapter. And then I'm just going to plug that into my computer. Connect that to Linux. So I'm going to go ahead and open up the boot file system, and you can see this here. So this is the image file that we're going to go ahead and replace. I'm going to go ahead and just kind of rename this to image.orig. It's not a bad idea when you're in development just to make copies of what you're changing. And then I'm going to copy the new image to this directory. And just to be able to show you where this is, we're going to go ahead and just run an lsblk here. So media John boot is this case. It's a /dev/sde1, but that's not material. What you really need is this path. So I'm just going to cp the kernel that we just built. So that's in temp deploy images edmg image. And there are several different files, but image here is just a symlink to this which was just built, that long file name. And then I'm going to copy that to media John boot. And you see it was just put here. Now we're going to go ahead and eject these because we want it to be nice and graceful with our media so that we don't eject and have the file half written or cached on our host. So I'm going to go ahead and pull that out. And I'm going to pull it out of my adapter here. And I'll plug that into the board. I'm going to turn the power on. Go ahead and hide that first. Okay, so before that, I want to do, hold on, I'll reboot again here. Now what I want to do is I want to show you that we have to still run explicitly the command mmc nfs boot, because otherwise we'll run the default boot command. Scoot. Okay, so life is good. So if everything worked out well with our kernel, we'll be able to proceed. And it looks like it is. So let's just continue to let it boot here. I'm going to make this a little bit bigger. So root. Now let's see if we're really mounting the root file system, the NFS root file system. To do that, we can just run the df command. So the df command shows you the mounted file systems and their usage. In this case, we're just seeing that that we have mounted an NFS directory here as the root file system. So that appears to be working. Now let's just double confirm. In theory, one of the advantages of having this is that you can create files and exchange files very easily between the host and the target. So let's just go ahead and do that. So I have this opt Yocto support NFS root. I'm going to go to home root here because that's where I am. Oops. Sudo su. And so there's nothing in that right now. There's nothing in this. If I just pwd, I'm in home root on the target. Now I'm just going to touch a file. My file. ls. So we see that there's a file in my file here. Again, this is in our host file system, but that's being exported as an NFS file system. Now if I just do ls here, I see my file. Life is good. So what about going the other way? Let's do this. Touch another file. ls. So there's another file. Okay, ls-al. And I have another file here. So we verified that our NFS root file system is working and that we are able to, in fact, exchange files between the host and the target. That concludes this particular tutorial and demonstration. Again, I'm John Weber with TechNexion. Thanks for watching.